Japan has always been ahead in robotics, but what was revealed at this expo shocked even experts. These machines don't just assist humans anymore. They interact, adapt, and learn in ways never seen before. Join us and let's discover the new robotic trend Japan just unleashed on the world. Let's go.
Number 13. Kawasaki Koro Cyberhorse. Koro stole every headline from the humanoid robots with its four-legged design that slams together Kawasaki's robotics knowledge with their legendary motorcycle heritage. This Cyberhorse shows the company believes wild new transport options will define how people move in coming decades. You ride Koro like a living animal, galloping over rocks, gravel, grass, and rough terrain that stops wheeled vehicles cold. The robot runs on hydrogen power, spitting out only water as exhaust. An integrated screen shows stability readings, fuel levels, and even lights up spots where your feet should go when darkness drops. At the booth, Koro became the poster child for robotic personal mobility, where rider and machine melt into one system. The design throws conventional thinking out the window. Instead of building another car or motorcycle, Kawasaki asked what mobility looks like when you remove roads from the equation entirely. The four legs handle natural terrain that would destroy suspension systems on traditional vehicles. The hydrogen engine addresses pollution concerns while delivering range that makes it practical for actual use beyond short demos. This machine proves innovation sometimes means stepping away from making robots look human and instead building machines that do things humans cannot.
Number 12. Fanuc M2000IA Heavy Payload Robot. Fanuc demonstrated why Japan still dominates industrial robotics with their M2000IA series at IREX 2025. This lineup includes the strongest 6-axis robot on the market, handling capacity up to 2.3 tons with reach up to 4.7 meters. These machines do not just move massive weight around, they control it perfectly, while adhering to designating working areas with precision that seems impossible for something lifting car engines and large machinery components. The M2000IA/1200 model hoists 1,200 kilograms with outstanding vertical lifting stroke. The M2000IA/2300 pushes limits further with 2,300 kilogram capacity. Dynamic control software manages speed and position control with accuracy that matters when handling expensive components or dangerous materials. Companies can add IR vision and airproofing technical vision for extra security when stakes get high. The exhibition displayed various grippers designed for these industrial manipulators, including vacuum grippers and soft grippers for delicate work with complex solids. These robots fill needs in automotive and heavy machinery industries, where human workers cannot safely handle the loads or maintain the precision required. IP67 protected wrist and shoulder-mounted motors mean these machines operate in harsh environments with dust and liquids without breaking down. The M2000IA series represents decades of refinement in industrial robotics, where reliability and precision matter more than flashy features.
I'm going to ask you a simple question. Are you a naturally curious person? If you're watching, I'm pretty sure the answer is yes. This space is made for people like us. To ensure you're always part of this community and receive all our latest discoveries, you just need to do one thing. Subscribe to the channel. It's the best way to stay connected with us. Okay, now that you're part of our Legion of the Curious, let's move on to the next item.
Number 11. Lumos Robotics Lus Humanoid. Lumos Robotics arrived at IREX 2025 as a Chinese startup founded only in 2024, but already presenting a full-sized humanoid robot. Standing 160 centimeters tall and weighing 60 kilograms, the LUS robot delivers extreme reactivity as its killer feature. The machine gets up off the floor in less than 1 second, demonstrating exceptional dynamics and balance recovery that sets it apart from slower competitors. The second-generation LUS2 uses advanced motion control modules and high-performance actuators with high torque density, plus tactile sensing technologies for object grasping. The robots run their own embodied AI systems, integrating vision, language, action, and tactile feedback for more accurate environmental interaction. Lumos is developing rapidly beyond full-sized humanoids into small home modules, modular components, high-sensitivity sensors, and robotic arms. The company already raised nearly $28 million in investment capital for this development work. The speed of progress shows how generous Chinese financial support for robotics companies creates intense competition even for established Japanese firms. Lumos focuses on making robots that react faster and more naturally to changing conditions, rather than just executing preset routines. The quick stand-up capability matters enormously for real-world deployment, where robots will fall occasionally and need to recover without human help. Tactile feedback lets the robot adjust grip strength and handle delicate objects safely. The embodied AI approach means the robot learns from experience rather than requiring complete programming for every situation.
Number 10. Sububame Arzac's giant pilot robot. Missed Gundam at IREX this year? The second largest giant robot in Japan made appearance instead. Arzac's was not just standing there looking impressive. Visitors could climb inside and try controlling its arms directly. The 4.5-meter-tall robot now comes equipped with 4 internal screens. Teleoperation lets operators move arms and fingers with intuitive controls. The robot itself can also move, but this feature remained unavailable inside the exhibition hall for safety reasons. This fulfills childhood dreams of piloting giant robots seen in science fiction movies and anime. According to Sububame Industry CTO Ishihari, the main goal was making it cool and ensuring it moves properly. The robot delivers on both counts. Sitting inside cockpit surrounded by screens while controlling massive mechanical arms creates unique experience. The controls translate human movements into robot actions at larger scale. This represents a different approach to robotics focused on human amplification rather than autonomy. The operator provides intelligence and decision-making, while the robot provides strength and scale. Applications include construction, disaster response, and industrial work, where human judgment combined with mechanical power solves problems neither humans nor autonomous robots handle well alone. The giant robot category remains niche, but addresses real needs in specific scenarios.
Number 9. Mechmine Robotics Vision System. Mechmine Robotics demonstrated their unified system at IREX 2025, calling it eyes, brain, and hands working together. The system combines 3D vision, artificial intelligence, and precise manipulators into one integrated package. At the booth, robots independently found objects, grabbed them accurately, sorted items, folded clothes, and confidently worked with things that challenge ordinary grasping systems. Their embodied intelligence technology makes robots autonomous agents capable of seeing, analyzing, and acting in the real world, rather than just executing preset commands. Mechmine positions itself as a leader where AI, sensors, and mechanics become a single whole. Their developments already operate in automotive, metalworking, and logistics industries. IREX 2025 served as a platform to demonstrate these technologies are ready to move beyond factory floors into service scenarios. The vision system uses 3D cameras that perceive depth and shape rather than flat images. This depth perception lets robots understand object orientation and plan approach angles for reliable grasping. AI processes visual data to identify objects even when partially obscured or in cluttered environments. The precise manipulators execute plans with accuracy that prevents damage to delicate items. Clothes folding demonstrates advanced capability since fabric changes shape and behaves unpredictably compared to rigid objects. Companies deploying Mechmine systems report significant improvements in automation rates for tasks previously requiring human dexterity and judgment. Number 8. Unitree Go2 Quadruped Robot. Unitree Go2 represents the company's latest evolution in quadruped robots, showing up at multiple IREX 2025 booths demonstrating hybrid wheel-leg kinematics. The four-legged platform navigates stairs calmly, switches between walking and rolling modes, and adapts its movement strategy based on terrain conditions. Built with the same motor technology that powers their humanoids, Go2 delivers impressive performance in a dog-sized package. The robot handles slopes, obstacles, and uneven surfaces while maintaining stability that keeps payloads secure during transport. Companies demonstrated Go2 in warehouse settings, moving between different floor levels, something wheeled robots cannot manage without ramps or elevators. The hybrid system means the robot rolls on wheels across smooth floors for speed and efficiency, then deploys leg movements when encountering stairs or rough terrain. This flexibility makes it practical for real industrial environments where facilities contain mixed surfaces. Go2 uses computer vision and sensors to map spaces and avoid obstacles autonomously. The platform can patrol areas, inspect equipment, or transport materials through complex environments without human guidance. Battery life supports extended missions before requiring recharge. The compact size lets it access tight spaces where larger robots would get stuck. Multiple vendors showed Go2 as part of their automation solutions, proving the platform has moved beyond research demos into commercial applications, solving real logistics challenges.
Number 7. Facini Tora1 Mobile Robot. Tora1 takes a different path as the lighter, more athletic version of Facini's humanoid line. It packs 58 degrees of freedom plus stability and mobility that let it handle stairs and bumpy ground. The complex modular platform powers this robot across uneven surfaces and up stairways, hitting speeds around 2 km per hour on flat ground. Double One's party trick is adjustable height from 145 to 185 centimeters, letting it adapt to different tasks and squeeze into various spaces. It lifts 4 kilograms with each hand and fits work in stores, offices, factories, and outdoor areas where ground conditions change constantly. The two models reveal how robot makers balance competing priorities. Tora1 loads up on sensors and precision, while Double One cranks up mobility and flexibility. Different jobs need different strengths. A manufacturing task might need the sensing and precision of Tora1. A retail environment might value the mobility and adaptability of Double One more. The height adjustment solves real problems both robots face. Shelves sit at different heights. Workbenches vary between facilities. Being stuck at one height limits where robots can work effectively. The ability to grow taller or shrink shorter means one robot handles jobs that would otherwise need multiple models or custom installations. Number 6. Robros Igris Korean Humanoid. Among Chinese and Japanese companies, a few Korean ones raised their heads. Robros brought humanoid robot Igris to the exhibition, standing 164 centimeters tall and weighing 60 kilograms. It has 31 degrees of freedom, not counting the arms, plus 6 degrees of freedom in each hand. Current payload remains small at only 3 kilograms per hand, while operating time reaches about 2 hours, depending on workload intensity. Only hardware is ready, though. Software remains under development. Nevertheless, the company conducts real-world tests with logistics partners because Igris can already grasp and move objects reliably. Robros also sells humanoids to research teams around the world who need platforms for developing their own applications and control systems. The Korean robotics industry occupies an interesting position between Japanese industrial strength and Chinese aggressive expansion. Companies like Robros focus on hardware excellence while leaving software flexibility open for customers to customize. This platform approach lets researchers and companies build on solid mechanical foundation without starting from zero. The focus on logistics applications makes business sense, since warehouses and distribution centers need automation desperately. Labor shortages and rising costs push companies toward robotic solutions. Humanoid form factor offers advantage in environments designed for human workers, where robots need to navigate stairs, reach different shelf heights, and manipulate various package sizes.
Number 5. Kawada Robotics Nextage Industrial Cobot. Kawada Robotics stood out at IREX 2025 by focusing on robots they have been creating and training for years. Although these machines have humanoid form, they function essentially as cobots, agile manipulators standing on assembly lines next to people. Nextage robots were positioned away from Chinese humanoid crowds in the industrial robot zone where they belong. These two-armed cobots already work on assembly operations in electronics and electrical engineering, making electronic toys. They help assemble ATM components and terminals for Glory Limited and participate in production stages across car manufacturing, cosmetic, and food industries. The robots have machine vision and perform close-call operations with both solid and soft objects. For example, they gently peel protective film from devices or double-sided tape, tasks requiring precise force control. Several companies demonstrated Nextage robots at their booths, showing applications across various scenarios. This widespread deployment proves the platform delivers reliable performance in real production environments. Kawada focused on practical industrial applications rather than chasing humanoid hype. The company built reputation on robots that work rather than robots that demo well. Years of refinement show in smooth movements and reliable operation. These machines represent mature robotics technology solving real manufacturing problems every day.
Number 4. Zizai Railway Infrastructure Robot. The most gigantic robot at IREX 2025 was Zizai, heavy-duty machine created specifically for servicing railway infrastructure. It drives on rails and roads and performs jobs at significant heights under serious pressure.
Operators control robot movements through intuitive natural controls. Cameras installed on ZZI give operators complete view of work area. The two-armed power platform on massive base handles operations at heights over 10 meters. Tasks include painting support structures, pruning trees along tracks, working with contact networks, and handling large infrastructure elements. ZZI has been exhibited before, but its younger brother, the ZZI ZX3 robot, made first public appearance at this show. ZX3 is more compact, maneuverable, and works in tighter spaces. In Tokyo demonstrations, the robot lifted and held large tools while performing precise movements requiring both strength and stability. The main principle is human-machine integration, where operators control robot arms in real time, while the system compensates for mass, vibrations, sudden movements, and external loads. This turns complex, dangerous labor into controlled procedure. Railway maintenance traditionally requires workers at dangerous heights with heavy tools. ZZI eliminates most human risk while improving precision and speed. The platform proves that giant robots serve practical purposes beyond entertainment when designed for specific, challenging tasks.
Number 3. Lynx Dynamics Ali Humanoid. Lynx Dynamics promoted their humanoid robot Ali at IREX 2025 as another Chinese startup delivering impressive results quickly. The humanoid market in China resembles a bubble with dozens of companies launching similar products, but Lynx Dynamics builds from an experienced team rather than complete newcomers. Their humanoid stands about 165 centimeters tall, weighs 55 kilograms, and has over 30 degrees of freedom plus their own drive system. Ali demonstrates balanced walking, fast stability recovery, and the ability to stand up after falling, which are key skills for working in human environments. The company emphasizes practicality with robot architecture open to developers through a Python SDK and tools for training, manipulation, and navigation. Lynx promotes Ali as a platform for embodied AI capable of performing basic tasks like carrying objects, simple manipulations, and moving over uneven surfaces. The main advantages are accessibility and trainability rather than groundbreaking hardware innovations. The open development platform lets researchers and companies customize Ali for specific applications without starting from scratch. Python SDK means developers can use familiar programming tools rather than learning specialized robotics languages. The focus on training and learning sets Lynx apart from companies selling robots with fixed capabilities. Customers can teach Ali new tasks as their needs evolve. Number 2. Kawasaki Kaleido 9 Rescue Robot. Kawasaki Heavy Industries showed up at IREX 2025 with machines that prove Japanese engineering still packs a punch. The star player, Kaleido 9, stands 180 centimeters tall and weighs 80 kilograms. This beast tackles disaster zones, clears rubble, and walks straight into environments filled with fire or hazardous materials without breaking a sweat. The machine lifts objects up to 18 kilograms and pushes heavy equipment weighing 30 kilograms without losing balance, even when movements get jerky and unpredictable. It works in 2 distinct modes: autonomous operation using preset commands and sensor data, or teleoperated control through advanced telerescence technology. When clearing debris, human operators take the wheel because it keeps the robot safer. The operator performs an action, and the machine copies it with exact force and timing needed for rescue work. For complex demonstrations, the system flips to partial or full autonomy, since no human can predict every obstacle the robot faces in chaotic environments. This rescue robot represents years of development focused on one goal: getting into places too dangerous for humans and doing the heavy lifting that saves lives. The balance system keeps it stable even on unstable ground covered in debris and broken structures.
Number 1. Kawasaki KAB Laboratory Robot System. Kawasaki Applied Biotech drops automation into laboratory environments through their KAB robotic system. This smart setup uses industrial robots for boring and dangerous lab work that eats up researcher time and attention. The robots grab test tubes, prep samples, load them into analyzers, and wire different instruments into one smooth automated assembly line. Labs flip switches to reconfigure the system for different jobs, including clinical tests, PCR analysis, handling nasty viruses, or pharmaceutical research that demands precision down to microscopic levels. The robots blast through work quickly and accurately without the mistakes humans make when doing the same boring task for the 1,000th time. This pumps out stable sample processing and high throughput that speeds up research timelines dramatically. Industrial robots own manufacturing floors but remain rare in lab settings. The KAB system shows how battle-tested robotic tech adapts when properly matched to new environments. Speed matters in labs. Precision matters even more. One contaminated sample or measurement error can trash entire experiments and waste months of work. By automating these danger zones, the platform frees expensive trained researchers to focus on actual science and discovery instead of playing lab assistant moving tubes around all day.
Still curious? Then don't stop now. The next mystery is already waiting for you. Just click the video on screen. I saved it just for you. See you there, curious one.